Hello YouTube, Rohan this side. So in today's video, I will be covering interesting interview questions which is getting frequently asked from DevOps engineer if they have experience in handling AWS EKS cluster. So the question is how you can connect your pods which is running inside your EKS cluster to AWS services. So you can answer it by giving EKS Pod Identity or your OIDC in service account. But in this video, I will be explaining or creating a POC using EKS Pod Identity. And in my next video, I will be trying to cover the other approach, which is IRSA, which is IAM role for your service account using OIDC. So first, we will try to understand what is EKS Pod Identity. So applications in a pod container can use the AWS SDK or CLI to make API requests to the AWS services using IAM permissions. So for example, the pod want to upload files to S3 bucket or they want to query some DynamoDB access. EKS pod identities manage these credentials similar to EC2 Instance Profiles. So instead of distributing AWS credentials manually, you can associate an IAM role with a Kubernetes Service Account and configure your pods with it. So in short, or in simpler terms, using EKS Pod Identity, if your application is running inside a pod, so you can try to access AWS SDK or CLI to make some requests to your AWS services with IAM permissions. So we just need some IAM permissions, which we will associate to the Kubernetes service account, and that service account will be configured inside the pod. Not inside the pod, maybe configure for the pods, which we want this association to be created. So these are the benefits of how you can utilize EKS pod identity. So the first is least privilege. You can scope IAM permissions to the service account, so only pods using that service account have the access to those permissions. So this will eliminate the need for third-party solutions like KIAM or Q2 IAM. Next, we have credential isolation. So a pod container can only retrieve credentials for the IAM role associated with the service account they use. And containers never have access to credentials used by other containers in other pods. Auditability. Access and event logging are available through your AWS CloudTrail to facilitate retrospective auditing. Next, we have independent operation. So in many organizations, creating OIDC identity provider is the responsibility of different teams than your admin Kubernetes cluster. EKS Pod Identity ensures a clean separation of the duties, with all configuration of your EKS Pod Identity associations done in Amazon EKS, and all configuration of IAM permissions done in IAM. Reusability. So EKS Pod Identity uses a single IAM principal instead of separate principals for each cluster that IAM roles for service account use. Your IAM admin adds the following principal to the trust policy of any role to make it usable by EKS Pod identities. Last, we have scalability. So each set of temporary credential is assumed by the EKS auth service in your EKS Pod identity. So instead of each AWS SDK running in each pod, then the Amazon EKS Pod identity agent running on each node issues the credentials to the SDKs. Next, we have this architecture diagram of EKS Pod Identity, or you can say the workflow, which we will be following through this video. And this is how we will be creating a demonstration video. So you can understand that we have a pod and a service account, which are a native resource of Kubernetes. So in the first step, you can see that pod is having a link with service account, and the service account is having a link with pod, which is pod identity agent. So using EKS Pod Identity, we have a pod which is running as a daemon set in each of your node inside your cluster. So this agent is the one which will be helping the service account to get the access for the AWS services. And this service account needs pod identity agent as well as some AWS IAM permission or IAM role, which we will create when we will start the video, so that only the pods which have the service account, and they will be using the specific service which they want to get access. And after that, if the permission is done and the pod identity agent is also installed inside your cluster, then your pod can try to access to the X3 bucket. So this is the flow which we will be also following throughout the video for creating this POC. So this is all for the presentation slide, and let's jump directly inside my Kubernetes cluster. So here I'm using a EKS cluster. Let me close this. Okay, so this is my Kubernetes cluster, and yes, so this is the one I'm using here, and which is running 1.30 version. So I have used EKCTL to spin up this cluster, and if you also want to use EKS for creating this EKS cluster, then you can use this repository, and inside this repository I have created a readme file, so you can follow along to create a EKS cluster in your AWS account. Okay, so for this demo, I will be using this repository, and I don't have anything which I can add in the readme file because I'm just applying these to YAML manifest file inside the cluster. So first we will go with the deploy.yaml, where I'm just simply creating a Nginx application with the replica 1, and here the important part is I have declared or mentioned the service account name which I will be using for the EKS Pod Identity demo, which is nginx-sa. So for creating the service account, I'm using this YAML, which is a very simple YAML, that this is the name of the Nginx, means the service account, and everything is running inside our test namespace. So let me first create the test namespace, which is nstest. Okay, so the namespace is created. Let me directly create this deployment.yaml file, nano deploy.yaml. Okay, so yeah, it's done. Now let me create a SA file as well. First copy this nano sa.yaml. Okay, so this is also done. Let's move outside. Okay, so now let's just apply kubectl-s and everything which is inside this directory. So deployment is created and the service account is also created. Let us check the pods running inside this namespace. Okay, I think, let me modify this. I think this is not modified. Okay, yeah, there are three replicas. I just need one for the simple demo, so I will apply the files again. Okay, kubectl apply. Sorry, just check kubectl get pods hyphen and test. Okay, so my one replica is running. Now let us try to move inside this pod so that we can check if we are able to access the AWS services without EKS Pod Identity or not. Okay, so I have to mention the namespace as well, which is test exec -it minus and test, then the pod name, then / bin sh. Okay, so now we are inside this pod, and here you can see the content. So first, let us try to first install AWS CLI, but let's first update the packages inside this pod, and we will be requiring unzip package as well, so let's install that as well. Okay, so for AWS CLI, I will be following this official documentation from AWS itself. Just copy and paste. After this, I will be requiring this last step so that I can move the unzipped content inside bin location. Okay, now let us check if AWS CLI is correctly installed or not inside the pod. Okay, we can see the version of AWS CLI, Python, Linux, and all other dependencies. Now let us try to list down the S3 bucket which is running inside my account. So here you can see that we should get this error because we don't have the permission to associate our pod with the bucket, or we are not even we are not able to list down the buckets. So it's of no use. Now let's get exit from this pod, and now let's go to the AWS console. So for this, we have to select the cluster name where we want to do the add-ons. So first, we will click on add-ons, and here the add-ons which is installed default by EKCTL. These are the list which is getting displayed here. So we just have to click on get more add-ons, and we have to search for EKS Pod Identity Agent. So see, Amazon EKS Pod Identity Agent is here, and we just have to check this checkbox and hit on next. The next and create. So now after this, our Amazon EKS Pod Identity Agent add-on is added inside our cluster so that we can now utilize this add-on inside our cluster. So after that, we just have to hit the access tab, and here we have to check pod identity associations. So this is the tab where we will be associating our service account with the IAM role so that the connection can be established, and then our pods, which is attached to the service account, can utilize this identity pod agent. Okay, so first we have to create a IAM role according to the flow. So we have done the installation for the pod identity, but now we are just left with AWS IAM role. So for that, we will hit on IAM and click on roles. We will create a role, and here we will select AWS service, and in this below drop down we will search for EKS, and here we will select EKS-pod identity. Allows pods running in Amazon EKS cluster to access your AWS resources. We will click on next, then we will search for S3. So just for this demonstration, I'm using Amazon S3 full access, but I will never encourage anyone to directly use this full access. So please use it accordingly to your needs and to your requirements. Now we will hit on next, and here in the trust policy, you can see that we have an effect of allow, and inside the principal service, we are simply using pods.eks.amazonaws.com. So as what we have mentioned inside our benefits, you can see we are reusably, we are just like using this feature of reusability because we are not creating separate principal for each cluster. We are just using a single IAM principal, and that can be easily used by the EKS Pod Identities. Okay, and after that, these are the actions which will be performed using this policy, and let's give some meaningful name. EC2, sorry, EKS Pod Identity hyphen role. Now just create this role. Okay, the role is created. Okay, so now we will again go back to the EKS dashboard, and we'll click on create. So we will now select roles. Okay, so it has taken the correct role, which is EKS Pod Identity role, and inside Kubernetes namespace, as our application and the service account is created in test namespace, so we have to use that. And the Kubernetes service account, we have to pass the name of the service account. So suppose if there are some scenarios where you don't remember or you are not able to access, like what is the service account your pod is running, means using, so you can use kubectl get pods -n test, then kubectl get pod and the name of your pod, then the namespace and -o YAML. Okay, so now it has all the default and all other mandatory fields of your pod. So here you can see service account name is engine x-sa. Although we can easily see the YAML which we have already applied, but if there are some circumstances where you are not able to get or retrieve the service account name, then you can directly use this as well. So here we will be using this service account name, and yeah, we will just click on create. So now our association is done. We will just refresh this page. Okay, pod identity association. So yeah, see the namespace and the service account is also done. IAM role, and this is the association ID. So you can also check if your cluster has associated this pod identity agent, or your pod identity agent is running successfully or not. So you can check this by using kubectl get pods -n kube system. So here you can see that there are two pods which is running this agent. So as I have already mentioned that EKS pod identity agent works as a daemon set, so it will be automatically installed or executed in each of the nodes where your clusters are having. So as I have two nodes, so I have two pods. or the two dimension. Okay, so now here we can verify that our pod identity agent pod is also running. So we can follow the process now. So here, according to this list, we have created the policy, the role, as well as this pod identity agent pod is also running, and these both are currently synced with our service account, and this service account is also uh, synced with our pod. So now we will try to access S3 bucket. So again, we have to check the pods inside the namespace, kubectl exec -it -n test, then the pod name, then bin sh. Okay, so now we are inside this pod, AWS S3ls. Okay, so we are still seeing this issue. So what we can do, we can try to restart our application or restart the pod. kubectl delete pod and -n test. Okay, the pod is deleted. Now let's check the new pod. kubectl. Now we will move inside this pod. -it -n test. Then this pod this shell. Okay. So now let's check. Okay, so I think we have to again install those dependencies, or means AWS CLI and unzip package. apt install unzip -y. Okay, now again I will be referring this. Yeah, okay, copy and paste. Okay, done. Okay, so I think AWS CLI is also installed correctly. Fine. So now we will try to list down all the S3 buckets. So my main target is to check and to do some operations on this bucket, so that whatever operation we did in our inside our pod, then it should be reflect inside this bucket. So AWS S3ls, and boom, we can list down all the S3 buckets and EKS Pod test bucket. Let us look for this. Okay, we can also check this. Okay, so we are now able to do list operation for S3. Now let's create a directory, make directory, and try to create a file and upload that into our S3 bucket. And after that, we will verify that our agent is working correctly or not by having a association with pod with our S3 bucket. Make directory demo. Now let's move inside this demo and just I'm creating a simple file which will have a single line. This line is written inside the pod to be get uploaded in S3 bucket, and I will be appending this text to hello.txt file. Okay, let us check if this is appended or not. Okay, fine, perfect. So now I will just simply use AWS S3 copy. Okay, I think I have to move first from this directory. Okay, yeah. So now AWS S3, copy this demo slash hello.txt to S3, and our bucket name is EKS Pod test bucket. EKS Pod test bucket. Okay, so I think this file is uploaded. Now let us check if we are able to see this directory or not. See, so our hello.txt is uploaded here, and let us download this and see. So here you can see the content which I wrote inside the pod is also getting reflected here. This line is written inside the pod to be get uploaded in S3 bucket. So this is how you can utilize pod identity agent, or in short EKS pod identity, to connect your Kubernetes pods with your AWS resources. I hope I was able to explain you this topic, and in the coming days I will be also explaining another approach using IRSA or IDC, so that you can have a look that which approach is better for your project or for your understanding. And yeah, I hope everything is going good, and thank you for your time.